Okay, so today we'll discuss chemical properties of alkane. Last class we started hydrocarbons and alkane. Now today we'll discuss chemical properties of alkane. So in the slide everything is explained, and on top of that, of course, we are going to discuss. So just see the slide and explanation point wise I'll give you. It's easy topic, hydrocarbon. Some mechanism which we will discuss related to the reaction will be covered at the end of hydrocarbon topic also. One second. So we discussed already about substitution reaction in GOC also, right? And related with that, in this hydrocarbon alkane, we are going to discuss one or more hydrogen atom of alkane can be replaced by halogen family, anyone, chlorine, bromine, iodine, nitro, sulfonic acid at high temperature or in presence of light. These reaction are substitution. So H will be replaced. Remember, H will be replaced by halogen, nitro group, sulfonic group, and similarly some other group also, right? So all these are substitution reaction. So let's discuss one by one. Halogenation. Halogen is added in that. What is the temperature? 573 to 773 Kelvin. Okay. In presence of diffused sunlight. Diffused sunlight. Now, what is this diffused sunlight? Like the sunlight which is coming in our room. Generally, not direct sunlight we are talking. We are talking about diffused sunlight. The temperature is 573 to 773 Kelvin. Remember, the SI unit is Kelvin scale. So in Kelvin scale, the temperature is given. So this is an example, like methane, basic example. The first member of alkane family, methane, Cl2, right? H nu means it is basically example that sunlight is there. There is nothing but the diffused sunlight. CH3Cl, chloromethane plus HCl. Now CH3Cl plus Cl2. Again, one more. See here there are 4 hydrogens, right? One hydrogen has been replaced. One hydrogen has been replaced. Now the second, we can see here is still 3 more hydrogens are there, right? Remember, this is proceeding through the free radical mechanism that we'll discuss later on, that how the we are having that free radical, methyl free radical and chlorine free radical, all those things. For the time being, try to understand the reaction itself. Then second part of that will be reaction mechanism, how it is formed, right? Many people are forgetting about reaction. So first try to understand the reaction. Chloromethane, one more chlorine, one more mole is added, then dichloromethane, 2 hydrogen has been replaced, right? So you can see this one. So first one chlorine, one hydrogen has been replaced, chloromethane. Then one more hydrogen has been replaced, dichloromethane has been formed. Still, there are 2 more hydrogen, right? 2 more hydrogen. So again, CHCl3, trichloromethane, common name chloroform, and then HCl. So we have trichloromethane, chloroform plus HCl will be there. Chloroform plus Cl2, again H nu, means sunlight, we are talking about diffuse sunlight, tetrachloromethane plus HCl. So at last, all hydrogen of methane has been replaced by halogen family member chlorine here. Finally, we are getting tetrachloromethane, right? Any doubt, anyone? Let's talk about higher member, ethane. Again, similar reaction, chloroethane, right? Similar reaction, chloroethane plus HCl. Okay. The mechanism for this will be, as I already told you, it's a free radical mechanism. Free radical mechanism involves 3 steps. Initiation. First step, free radical formation. then propagation, and finally it will be termination. Termination state, all free radical will combine together and start giving the molecule itself. Remember, the free radical is intermediate. It has to combine with some other free radical to give the product. So last step is termination. So initiation, propagation, and termination. Initiation. It has to initiate. As the name itself is suggesting, initiation. It has to initiate. So how it will initiate? Homolysis. If you remember, we discussed homolysis. What is homolysis? The electron will be distributed equally, right? Free radical will be formed. Remember, there is no cation, no anion formation here. Free radical formation will be there. Cl-Cl bond is weaker than CC and CH bond. So Cl-Cl bond will break. And Cl free radical will get homolysis. Cl, and what we'll do? We'll put one dot like this. So that is a representation of electron. Both are taking their own one electron. Remember, there is no excess of electron. There is no excess of electron. There is no lack of electron. Right? That's what we are getting here. Free radical. Cl free radical, chlorine free radical, chlorine free radical. So both are free radicals. Okay. Next step will be the reaction between a propagation between a molecule and free radical. So the molecule already we know. Now chlorine free radical is there, methane molecule. It will attack, then methyl free radical will be formed. It will take that H from there, and HCl will be formed. So methyl free radical is formed, right? So this is propagation. Methyl free radical is there, and already in first step we know that we have one chlorine free radical. See here that one chlorine free radical we are using here, but last step we got two chlorine free radical, right? So even if we'll talk about here, as we can see now in the termination step, right? And in propagation step, as you can see here, CH3Cl, one free radical is formed here. So CH3 methyl free radical with chlorine free radical will form CH3Cl. Now this will keep repeating it before the final product. And finally, termination, all possible free radical combination will be there. The reaction between any two free radical is known as chain termination reaction. It means now free radical, which is an intermediate, will be consumed fully, right? Cl, Cl2, all possible, remember. Methyl, then ethane, methyl and chlorine free radical, CH3Cl. So finally, all free radical. See, basically two free radical was formed, chlorine and methyl. So finally, we are getting this. This is third step, termination. So we have initiation, we have propagation, and finally we have termination. So initiation step, chlorine free radical will be formed, chloride free radical will be formed. Second step, methyl free radical, methyl will be so this free radical basically it comes here, right? And then we are having CH3Cl plus Cl, then Cl free radical, Cl2 is formed. So this step will keep repeating it till we are having the product. Remember, whenever light is used, sunlight is used, peroxide is used, it is free radical mechanism. These 2-3 things is a golden rule you have to remember. Sunlight is used, peroxide is used. Here it is not used, but there can be some reaction. Generally, it will be free radical mechanism. So entire organic chemistry, if you'll see somewhere or sunlight or diffuse sunlight or something related with light, you have to understand free radical mechanism we are promoting there. Now this is one important point, rate of replacement hydrogen of alkane is 3 degree, then 2 degree, 1 degree. Already we discussed what is 3 degree. 3 degree carbon. Already we discussed the carbon which is connected with 3 other carbon, right? That is 3 degree carbon. Now connected with this, whatever hydrogen will be there, that is 3 degree hydrogen. 3 degree hydrogen. So if a hydrogen is connected with 3 degree carbon, that is called 3 degree hydrogen. So rate of replacement of hydrogen of alkane will be 3 degree, then 2 degree, then 1 degree. Rate of reaction with alkanes with halogen, right? F2, then Cl2, then Br2, then I2. Fluorine maximum, then chlorine lesser than that, bromine, then finally iodine. Basically, fluorine is too violent to be controlled. So that's what if you'll see most of the reaction, we will be talking here with the chlorine, even in the and bromine, because I2 will be too slow. This is too slow. This is too fast. Now in chemical kinetics also we discussed that too slow and too fast reaction we don't discuss. If it is too slow or too fast, we generally take for to study anything reaction with the moderate reaction rate. Okay. So fluorination is too violent to be controlled. Iodation is very slow and a reversible reaction. Iodination can be carried out in presence of oxidizing agent like HNO3 or HNO3 to make it a better rate of reaction. Right? So make it more better, more faster. Because it is too slow, we can use HiO3 or HNO3. Okay, now there are some MCQs. Try to answer it. Take your time, but try to answer. Formation of chloromethane takes place from methane, which chlorine in presence of sunlight is proceed through. Remember, whenever there is a presence of sunlight, then free radical mechanism we are going to take. Okay. The steps involved in halogenation of ethane. What are the steps? See, already we discussed 3 steps are there: initiation, propagation, and termination. Initiation, propagation, and termination. So all the 3. So the steps involved in halogenation of ethane is all the 3. Okay, so this completes this chemical reaction.